Q1. An organization plans to use the Anypoint Platform Audit Logging Service to log Anypoint MQ actions. What consideration must be kept in mind when leveraging Anypoint MQ audit logs? A. Anypoint MQ audit logs include logs for sending, receiving, or browsing messages. B. Anypoint MQ audit logs include logs for failed Anypoint MQ operations. C. Anypoint MQ audit logs include logs for queue create, delete, modify, and purge operations. The correct answer is C. Anypoint MQ audit logs include logs for queue create, delete, modify, and purge operations. Explanation: why C is correct. The Anypoint Platform Audit Logging Service tracks management and control plane actions, administrative changes. For Anypoint MQ, this includes queue and exchange lifecycle events such as creating, updating, deleting, or purging queues/exchanges, as well as managing client IDs and access keys. Why A is incorrect. Data plane message payload operations, sending, receiving, acknowledging, or browsing actual messages, are not tracked by the Anypoint Audit Logging Service to preserve performance and avoid logging high-volume payload data. Why B is incorrect. Audit logs record administrative actions taken by users or environments rather than operational/runtime message processing failures. Operational failures are captured via application logs or Anypoint MQ monitoring metrics. Q2. According to MuleSoft, which system integration term describes a method, format, and protocol used for communication between two systems? A. Component. B. Interaction. C. Message. D. Interface. The correct answer is D. Interface. An interface serves as a contract between systems, defining the specific protocols, e.g. HTTP, SFTP, data formats, e.g. JSON, XML, and access methods, e.g. REST endpoints, SOAP actions, required for two applications to connect and exchange data. Why the other options are incorrect. A. Component. In MuleSoft terminology, a component is an internal processing block within a Mule flow, such as a transform message logger or choice router. It executes logic inside the integration application, rather than establishing the transport protocols or contracts between external systems. B. Interaction. An interaction describes a dynamic pattern or event of systems communicating, e.g., synchronous request-response versus asynchronous publish-subscribe. It refers to the exchange action itself, not the technical specification, protocol, or structure defining how they talk. C. Message. A message is a data container transmitted during communication, comprising the payload, attributes, and variables in Mule 4. It is the actual content being transferred rather than a defined protocol, format, or method used to govern that transfer. Q3. An API implementation is being designed that must invoke an order API, which is known to repeatedly experience downtime. For this reason, a fallback API is to be called when the order API is unavailable. What approach to designing invocation of the fallback API provides the best resilience? A. Redirect client requests through an HTTP 3.03 temporary redirect status code to the fallback API whenever the order API is unavailable. B. Set an option in the HTTP requester component that invokes the order API to instead invoke a fallback API whenever an HTTP 4XX or 5XX response status code is received from order API. C. Create a separate entry for the order API in API Manager, and then invoke this API as a fallback API if the primary order API is unavailable. D. Search Anypoint Exchange for a suitable existing fallback API, and then implement invocations to their fallback API in addition to the order API. The correct answer is D. Search Anypoint Exchange for a suitable existing fallback API, and then implement invocations to this fallback API in addition to the order API. Explanation. In MuleSoft's architectural methodology, promoting asset reuse and discovering pre-existing capabilities via Anypoint Exchange is a core pillar of API-led connectivity, and the C for East Center for Enablement model. When designing for resilience against known downtime, architects should leverage reusable services discoverable within the organization's repository and implement fallback logic, such as using error handlers or retry scopes, to invoke the alternative API gracefully. Why the other options are incorrect. A. Redirect client requests through an HTTP 3.03 temporary redirect status code. HTTP redirects shift the failover responsibility back to the client application, creating tight coupling and poor user experience. Backend integration flows should handle failover transparently. B. Set an option in the HTTP requester component to instead invoke a fallback API. The Mule HTTP requester component does not have a built-in configuration property or toggle to automatically switch over to a fallback target URL upon receiving 4XX or 5XX status codes without explicit error handling logic, like a try scope or on-error continue. C. Create a separate entry for the Order API and API Manager. API Manager is used for governance, SLA tiers, and applying policies such as client ID, enforcement, or rate limiting. It is not a runtime routing mechanism for handling fallback failover logic. Q4. A retail company is implementing a MuleSoft API to get inventory details from two vendors by invoking each vendor's online applications. Due to network issues, the invocations to the vendor applications are timing out intermittently, but the requests are successful after re-invoking each vendor application. What is the most efficient way of implementing the API to invoke each vendor application and to retry invocations that generate timeout errors? A. Use a for each scope to invoke the two vendor applications in series, one after the other. Place the for each scope inside an until successful scope to retry requests that raise timeout errors. B. Use a choice scope to invoke each vendor application on a separate route. Place the choice scope inside an until successful scope to retry requests that raise timeout errors. C. Use a scatter-gather scope to invoke each vendor application on a separate route. Use an until successful scope in each route to retry requests that raise timeout errors. D. Use a round-robin scope to invoke each vendor application on a separate route. Use a try-catch scope in each route to retry requests that raise timeout errors. The correct answer is C. Use a scatter-gather scope to invoke each vendor application on a separate route. Use an until successful scope in each route to retry requests that raise timeout errors. Explanation. This scenario tests two key MuleSoft integration requirements: performance, parallelism, and resilience, isolated retry logic. Scatter-gather for performance. A scatter-gather scope executes both vendor invocations simultaneously in parallel threads across separate routes. This is the most performant approach compared to sequential execution, until successful inside each route for targeted retries. Placing an until successful scope around the individual HTTP call in each route ensures that if vendor A times out, only vendor A's request is retried. Vendor B's successful response will not be unnecessarily re-requested, maximizing efficiency and performance. Why the other options are incorrect. A. For each scope inside until successful. The for each scope processes items sequentially in series, making it significantly slower than parallel execution. Furthermore, placing until successful outside the for each means a timeout on the second vendor would force the entire loop to restart, re-executing the call to the first vendor even if it succeeded at B. Choice scope inside until successful. A choice scope executes conditional branching, if/else, meaning it will only invoke one vendor application or the other based on expression, rather than getting inventory details from both vendors. D. Round-robin scope with try-catch. Round-robin alternates execution between routes across sequential executions, Route 1 on call 1, Route 2 on call 2, rather than executing both routes for a single request. Additionally, a basic try scope catches errors but does not perform automatic reinvocations/retries on its own like until successful does. Q5. Mule applications need to be deployed to CloudHub so they can access on-premises database systems. These systems store sensitive and hence tightly protected data, so are not accessible over the internet. What network architecture supports this requirement? A. An Anypoint VPC connected to the on-premises network using an IPsec tunnel or AWS Direct Connect, plus matching firewall rules in the VPC and on-premises network. B. Static IP addresses for Mule applications deployed to the CloudHub shared worker cloud, plus matching firewall rules and IP whitelisting in the on-premises network. C. An Anypoint VPC with one dedicated load balancer fronting each on-premises database system, plus matching IP whitelisting in the load balancer and firewall rules in the VPC and on-premises network. D. Relocation of the database systems to a DMZ in the on-premises network, with Mule applications deployed to the CloudHub shared worker cloud, connecting only to the DMZ. The correct answer is A. An Anypoint VPC connected to the on-premises network using an IPsec tunnel or AWS Direct Connect, plus matching firewall rules in the VPC and on-premises network. Explanation: when CloudHub deployed Mule applications need to access on-premises systems holding sensitive data that cannot be exposed to the public internet. Anypoint VPC isolates the CloudHub workers within a private network segment instead of placing them on the public shared worker cloud, IPsec, VPN/AWS Direct Connect, establishes a secure, private, and encrypted communication channel between the Anypoint VPC and the corporate on-premises data center, allowing traffic to traverse using internal private IP addresses without traversing the open internet. Firewall rules ensure strict port level and protocol level restrictions on both ends to maintain defense in-depth security. Why the other options are incorrect. B. Static IP addresses on the shared worker cloud. Static IPs on the shared worker cloud still send traffic over the public internet. Whitelisting static IPs does not protect sensitive traffic from public routing, which violates a requirement for systems that are not accessible over the internet. C. Dedicated load balancer, DLB, fronting each database. In MuleSoft's architecture, a dedicated load balancer, DLB, routes inbound HTTP/HTTPS traffic from external clients into the Anypoint VPC. It cannot be placed in front of back-end database protocols like JDBC/TCP, located on premises.d, relocation of database systems to a DMZ. Moving core-sensitive databases to a DMZ still leave them exposed to external network segments and fails to provide secure private connectivity from CloudHub. Moreover, architecture should adapt to database security policies rather than forcing sensitive databases into public/DMZ zones. Q6. What is an advantage that Anypoint platform offers by providing universal API management and integration platform as a service, IPaaS capabilities in a unified platform? A. Ability to use a single IPaaS to manage and integrate all API gateways. B. Ability to use a single connector to manage and integrate all APIs. C. Ability to use a single control plane for both full lifecycle API management and integration. D. Ability to use a single IPaaS to manage all API developer portals. Q7. Insurance organization is planning to deploy Mule application in MuleSoft hosted runtime plane. As a part requirement, application should be scalable, highly available. It also has regulatory requirement which demands logs to be retained for at least 2 years. As an integration architect, what step you will recommend in order to achieve this? A. It is not possible to store logs for 2 years in CloudHub deployment. External log management system is required. B. When deploying an application to CloudHub, logs retention period should be selected as 2 years. C. When deploying an application to CloudHub, worker size should be sufficient to store 2 years' data. D. Logging strategy should be configured accordingly in log4j file deployed with the application. The correct answer is A. It is not possible to store logs for 2 years in CloudHub deployment. External log management system is required. Explanation: by default, MuleSoft's CloudHub platform limits log storage to 30 days or 100 megabytes per application worker, whichever comes first, after which older logs are overwritten and deleted. Even with enhanced subscriptions, like Anypoint Monitoring Titanium, Native log retention does not extend to 2 years. To satisfy long-term compliance and regulatory retention requirements, such as 2+ years for insurance or financial data, an integration architect must offload and store logs in an external log management system, such as Splunk, Elastic/ELK, AWS S3, or Datadog, by disabling CloudHub's default logging, or using appender/log4j configurations to stream logs externally. Why the other options are incorrect. B. Selecting a retention period of 2 years in CloudHub. CloudHub does not provide a deployment setting or drop-down parameter to set log retention to 2 years. C. Increasing worker size. Log retention limits in CloudHub, 30 days/100 megabytes per worker, apply regardless of the vCore size allocated to the worker. D. Configuring log4j file in the deployed application. While a custom log4j2.xml file is used to direct log appenders to external log aggregators, e.g. via syslog or socket appenders, configuring log4j2.xml alone does not store or retain the logs for 2 years without integrating with an external storage system. Q8. An API implementation is being developed to expose data from a production database via HTTP requests. The API implementation executes a database select statement that is dynamically created based upon data received from each incoming HTTP request. The developers are planning to use various types of testing to make sure the Mule application works as expected, can handle specific workloads, and behaves correctly from an API consumer perspective. What type of testing would typically mock the results from each select statement rather than actually execute it in the production database? A. Unit testing white box. B. Integration testing. C. Functional testing black box. D. Performance testing. The correct answer is A. Unit testing white box. Explanation. Unit testing focuses on verifying individual components, flows, or functions in isolation from external dependencies. In MuleSoft development, typically implemented using the MUnit framework, external operations, such as executing a dynamic select statement on a database, are mocked or simulated. Mocking database operations during unit testing ensures that tests run fast and deterministically without requiring an active database connection. Production data remains completely safe from unintended side effects during test runs. Why the other options are incorrect. B. Integration testing verifies that the Mule application interacts correctly with actual external systems and services, like a test/sandbox database. It tests the actual connection and queries rather than mocking them. C. Functional testing. Black box tests the end-to-end functionality of the API from an external consumer's perspective, without knowledge or mocking of internal components or database connections. D. Performance testing. Evaluate system throughput, latency, and stability under realistic or peak load conditions, which requires executing actual database queries to measure true system behavior. Q9. An API has been updated in Anypoint Exchange by its API producer from version 3.1.1 to 3.2.0, following accepted semantic versioning practices, and the changes have been communicated via the API's public portal. The API endpoint does not change in the new version. How should the developer of an API client respond to this change? A. The update should be identified as a project risk, and full regression testing of the functionality that uses this API should be run. B. The API producer should be contacted to understand the change to existing functionality. C. The API producer should be requested to run the old version in parallel with the new one. D. The API client code only needs to be changed if it needs to take advantage of new features. The correct answer is D. The API client code only needs to be changed if it needs to take advantage of new features. Explanation. Under standard semantic versioning, SemVer practices major, minor, patch. Major 3.x indicates breaking changes that require client updates. Minor x.2x indicates backward compatible new functionality or enhancements. Patch x.x.0 indicates backward compatible bug fixes. Moving from 3.1.1 to 3.2.0 is a minor version update. By definition, minor updates preserve full backward compatibility. Since the API endpoint and existing contracts remain unchanged, existing API clients will continue to function without any modifications unless they choose to adopt the newly added features. Why the other options are incorrect. A. Identified as a project risk requiring full regression testing. Minor version releases are backward compatible and do not introduce breaking interface changes, making them low-risk updates for existing consumers. B. Contacting producer to understand changes. Minor updates are already documented in the release notes and portal. Client developers do not need to negotiate or inquire about existing functionality breaking. C. Requesting the old version to run in parallel. Parallel deprecation strategies and side-by-side runtimes are reserved for major version updates, e.g. v3.x to v4.x, where breaking changes occur. Q10. When designing an upstream API and its implementation, the development team has been advised to not set timeouts when invoking downstream API. Because the downstream API has no SLA that can be relied upon, this is the only downstream API dependency of that upstream API. Assume the downstream API runs uninterrupted without crashing. What is the impact of this advice? A. The invocation of the downstream API will run to completion without timing out. B. An SLA for the upstream API cannot be provided. C. A default timeout of 500 milliseconds will automatically be applied by the Mule runtime in which the upstream API implementation executes. D. A load-dependent timeout of less than 1,000 milliseconds will be applied by the Mule runtime in which the downstream API implementation executes. The correct answer is B. An SLA for the upstream API cannot be provided. Explanation. An service-level agreement, SLA, defines performance guarantees, such as maximum response latency and availability metrics, for an API consumer. Because an upstream API relies directly on its downstream dependency to fulfill incoming requests, its overall response time is tightly bounded by the response time of that downstream service. If 1. The downstream API has no guaranteed SLA, and 2. No response timeout is set on the upstream API's outbound calls, the upstream API could potentially wait indefinitely for the downstream service to respond. As a result, the upstream API cannot guarantee a maximum latency or availability boundary to its own consumers, making it impossible to define or commit to an SLA. Why the other options are incorrect. A. The invocation will run to completion without timing out. While technically true if the downstream API eventually finishes, this statement describes a behavior rather than the primary architectural impact on the upstream API's service contracts and design constraints. C and D. Default/load-dependent timeouts applied by Mule runtime. Mule HTTP requested components do not automatically inject arbitrary internal timeouts like 500 milliseconds or dynamic sub 1000 ms rules based on runtime load unless explicitly configured. Default response timeout is 30,000 milliseconds unless overridden.
If this video helped clear up these MuleSoft concepts for you, please hit that like button and subscribe to the channel. It really helps support the content. But don't go anywhere just yet. Stick around and jump straight into the next video to keep building your integration skills.